In this tutorial, you'll learn how to set up a 3D DEM simulation of a hopper. First, create a new project by going to New on the main menu and selecting the blank template. Enter a name for the project and select a location to save to. On the Model Setup pane, enter a description, select the DEM solver, and disable the Fluid Solver. On the Geometry pane, we will use the Hopper wizard to create the geometry of the hopper. Press Apply to use the default values. Next, we'll press the Auto Size button to auto-size the extents to the geometry. We can see the primitive geometry objects and the Boolean operations in the tree. On the Mesh pane, we will enter the background mesh of 10 cells in the X direction, 25 cells in the Y direction, and 10 cells in the Z direction. On the Mesher subpane, we will uncheck External Flow, change the allocation factor to 1, change the facet angle tolerance to 0, and change the max facets per cell to 30. Next, we'll set up a couple of regions to associate with boundary conditions and initial conditions. First, we'll create a wall region by selecting the All button, entering a name. Next, we'll select the facets by checking the Select Facets checkbox. In order to use another boundary condition for the outlet, we need to deselect the facets in the Y normal direction. To do this, we'll select Filter Facets based on normals, select Include Equilibriant Vector, and Invert Selection. Next, we'll create a region at the bottom of the domain by clicking the Bottom button and change the name to Outlet. Finally, we'll create a region for the solids by clicking the All button, changing the name to Solids, change the color by clicking the Color button, and change the Y extents by dividing the Y min by 3 and enter 0 for the 2 value in the Y direction. On the Solids pane, we'll create a new solid and give it a name. Make sure that the DEM model is selected. Enter a diameter of 0.003 meters and a density of 2,500 kilograms per meter cubed. On the DEM subpane, we'll select Enable Automatic Particle Generation. Next, we'll create a new initial condition and select the Solids region. And enter a volume fraction of 0.4. Next, we'll create a new boundary condition and select No Slip Wall, and then select Walls from the list of regions. Next, we'll create another boundary condition for the outlet. Select Pressure Outflow and the outlet region. Finally, on the Output pane, we'll select Write VTK Output, and on the VTK subpane, we'll create a new output, select Particle Data, and the Background IC region. Next, we'll select the diameter and translational velocity output data, and change the write interval to 0.01 seconds. We can now run the simulation by hitting the Run button. Select the default solver and press Run. The simulation is now running, and we can see the output in the console. After some time has elapsed, we can create a new graphic window and select the VTK option. We can now see the results of the simulation. And color the particles by the data that was selected. Thanks for watching.